Again, welcome to operating system. This is CS332 class. So in this lectures, we're going to continue with the operating system overview. And our main goal of this section is to talk about the major achievements in operating system. So as we know, operating system, again, is one of the most complex pieces of software ever developed. It's one of the software with so many features, so many functions, and I think the most important is the software that normally can coordinate, also interact with the computer hardware. So it's one of the complex pieces of software ever developed. Now, the major advances in the development include processes, memory management, information protection, security, scheduling, and resource management, also system structure. As we compare the early operating system to our modern operating system, we can see a lot of improvement in these 5 items here, especially with the concept of multi-programming comparing to unit programming, or multi-processing system compared with a single processing system. This has optimized modern operating system, again, has optimized computational process, tasks, and etc. So each advance is characterized by the principles, also abstractions, developed to meet difficult practical problems. So taken together, these 5 areas will span many of the key design and also implementation issues of any modern operating system. And our course may focus on these 5 characteristics. So first, we start with the definition of a process. So again, the central to the design of operating system is the concept of a process. So the term was first used by designers of an operating system. And in general definition, we say that a process can be defined as a program in execution. So this means if a program is a set of instruction or code that perform a specific task. So if I create a code or a program and I save it in a storage device, it's called a program. But if this code is executing, then it's become what we call the process. So that's why we say the first definition of program in execution is called a process. And when we look at the second definition, it's also the same idea, an instance of a running program. So a program that is running, which means in execution. Or we may say the entity that can be assigned to, and also the keyword executed on a processor. Also the unit of activity characterized by a single sequential thread of execution. So the keyword here is execution, running, execution, running. So a process will be a program that is running or being executed. So we have some few causes of errors when it comes to, again, operating system concept. So again, the principal two are variable to system programmers. Normally, system programmers are the programmers that develop system software. As we said in our first lectures, there are 2 major types of software, either system software or application software. Application software will perform a specific task, such as Microsoft Word to create a resume, a computer game, etc. Now, system software is any software that interacts with computer hardware. And one of the major system software is operating system. We also have, for example, utility programs, antivirus, fragmentation or defragmentation software. All these are, again, system softwares. So again, the principal two are variable to system programmers in developing the earlier multi-programming and also multi-user interactive system was the interrupt. The concept of interrupt, again, we discussed that already. Now, if we want to do the concept of multi-programming or even a multi-processing means you may have 2 process or 2 programs executing at the same time. So they may go for the context, trying to use memory or other computer hardware resources. So we must know, allocate to them, to all the process at the right time, and also should be in sequential order. Interrupt means I will be doing something, maybe another processor have a high priority, one processor will stop, will be interrupted, and the other process will be executed. When you finish, the control will be given back to the previous process. So we may go more details about this concept. So as we know, the activities of any job could be suspended. And so that's activities of any job could be suspended by what? The occurrence of a defined event. An event can be I/O event, that's input, output, compression, etc. So in this case, a processor will save some sort of context. Example can be a program counter or other registers. And then it will branch to an interrupt handling routine, which again would determine the nature of the interrupt, then process the interrupt, and then resume user processing with the interrupted job or some other job. So the design of the system software to coordinate these various activities turned out to be remarkably difficult. So with many jobs in progress at any one time, each of which involved numerous steps to be performed in sequence. And also it became impossible to analyze all of the possible combinations of sequence of events. So this also can lead us to the concept of having some errors, because this effort can be very vulnerable to programming errors, whose effect could be observed only when certain relatively rare sequence of action occur. And these errors were difficult to diagnose because they need to be distinguished from application software errors and also hardware errors. So here we're going to talk about system software errors. So one is the improper synchronization. This is often the case that routine must be suspended, awaiting an event elsewhere in the system. So for example, a program that initiates an input-output read must wait until the data are available in the buffer before proceeding. So in such cases, a signal from other routine is required. Now, improper design of signaling mechanism could result in signals being lost or duplicate signals being received. And we may talk more detail about process synchronization in the future lectures. So another error can be a failed mutual exclusion, which again, we may discuss this in the future also lectures. But this is often the case that more than one user or a program is attempting to make use of a shared resource at the same time. So our goal is to avoid mutual exclusion, which means we have at least two or more processes trying to access or use memory or any computer hardware share resources at the same time. So again, for example, two users may attempt to edit the same file at the same time. This can again cause an error in the file system. Another error is non-determinate program operation. And this normally will result of a particular program normally share should depend only on the input to that program and not on the activities of other programs in the shared system. But when programs share memory and the execution is interleaved by the processor, they may interface with each other by overwriting common memory areas in unpredictable ways. So the order in which various programs are scheduled may affect the outcome of any particular program. And our last error will be the deadlocks. Again, we may cover this more detail when we cover process synchronization Here is again, it's again possible for two or more programs to be hung up waiting for each other. So for example, we have two programs, may each require two I/O devices to perform some operation, but one program have access to one of the I/O device and the other program have access to the other I/O device. So this means the two programs will be waiting for each other. Now we have some components of process. Here we say that a process normally contains three items: an executable program, and any executable program needed data. So associated data needed by the program, and also the execution context. For example, the process state. We may discuss about different state of a process. So again, the principal two are available to system engineers in developing the earlier multi-programming and also multi-user interactive system. As we mentioned earlier, was the interrupt. So activity of any job could be suspended by the occurrence of a defined event, such as an input and output compression. Also, the process will have some sort of context. Example, we have program counter or other registers, and may branch to an interrupt handling activities, etc. So again, the design of a system software is to be able to coordinate various activities, turn this again out to be remarkable difficult with many jobs in progress at any one time. So it's very, very difficult, especially we may multi-program system. We may have as many processes executing at the same time, or as many programs executing at the same time. Now, each of which involve numerous steps to be performed in sequence. So each process have some steps, again, different types of steps to be able to perform its tasks. So this became impossible to analyze all of the possible combination of sequence of events. And in the absence of some systematic means of coordination and cooperation among activities, programmers resorted to an ad hoc means based on the understanding of the environment that the operating system had to control. So again, process, as we said, and also execution context is essential because it is internal data by which operating system is able to supervise and also control the process, including the content of various process registers, including information such as the priority of the process and whether the process is waiting for completion of in particular I/O event. And again, we may discuss this more detail when we cover the process synchronization. So this is the concept of process management. So for example, here we have the process list. In the main memory, we may have process A, process B. Each process has its own data, program code, and also the context for each. So here we say the entire state of the process at any instance is contained in its context. So new features can be designed and incorporated into operating system by expanding the context to include any new information needed to support the features. So next we move to the concept of memory management. So before we move to memory management, one thing we should, as we said, we should know is that a processor normally consists of the three components: the executable program, the data that it needs, and also the execution context of the program. Now, next we move to the concept of memory management. So here we say the operating system has 5 principal storage management responsibilities. So here we can see the process isolation, which is which is one of them, and also automatic allocation and management, and support of modular programming, and the protection and access control, and also the concept of a long-term storage. So again, the needs of users can be met. The needs of a users can be met best by computing environment that supports modular programming and also the flexible use of data. So system managers need efficient and also orderly control of storage allocation. The operating system, to certify this requirement, has a 5 principal storage management responsibility, as we mentioned. So with the operating system, the process isolation, the operating system must prevent independent processes from interfering with each other. So the concept is process to isolate the process. So operating system must prevent independent processes from interfering with each other's memory, both the data and instruction. Now, with the automatic allocation and management, here programs should be dynamically allocating across the memory hierarchy as required. So allocation should be transparent to the programmer. So the programmer is relieved of concerns related to memory limitations, and also the operating system can achieve efficiency by assigning memory to jobs only as needed. Now, with the idea of support of modular programming, here programmers should be able to define program modules and also create, destroy, alter, and set size of modules dynamically. Now, protection. So again, now with the protection and access control, sharing of memory at any level of memory hierarchy, we need to create the potential for one program to address the memory space of another. And also we have the long-term storage. And here we see again, many application programs require means of storing information for extended period of time after the, again, computer has been powered down. Also, the next concept is virtual memory, which we are going to cover in detail. So here we say virtual memory normally is a facility that allows programs to address memory from a logical point of view, without regard to the amount of main memory physically available. So this is conceived to meet the requirement of having multiple user jobs reside in main memory concurrently. So a typical operating system meets this requirement with virtual memory and also files system. So a file system implements a long-term store with information stored in name object called files. Again, file is a convenient concept for the programmer and is a useful unit of access control and also protection for the operating system. Virtual memory is a facility that allows programs, again, as we said, allow programs to address memory from a logical point of view without the regard of amount of main memory physically available. So again, virtual memory was conceived to meet the requirement of having multiple user jobs residing in a main memory concurrently, so that there will not be any issue between execution of successive process while one process was written out to secondary store. And also the whole idea is trying to use the secondary storage device as a main memory. And again, we may go more detail on this. Also the concept of paging, here, a paging idea also we may go more detail now, but because process vary in size, we should know that if the processor switches among number of processes, it's very difficult to pack them compactly into main memory. So paging system were introduced. And the whole idea is that since, again, every process may vary in different sizes. So paging allows process to be comprised of number of fist-sized blocks called the pages. So paging system were introduced which allow process to be comprised of number of fist-sized blocks. So a program references a word by means of virtual address consists of page number and also an offset within the page. Now, each page of the process may be located anywhere in the main memory. And also the paging system provides for a dynamic mapping between the virtual address used in the program and also the array address or the physical address in the main memory. And we may discuss more details on this when we cover again virtual memory in the course. So this is a concept of virtual memory address. We have a processor, a main memory unit, but we also have the secondary storage and also the main memory. So it's the main memory management unit. The real address will be in the main memory. And the processor may have the concept of virtual address. But the whole idea again is using the secondary memory, like secondary storage concept. And next is the information protection and security. Now, the nature of a threat that concerns an organization will vary greatly depending on the circumstances. So the problem involves controlling access to computer systems and also information stored in them. So the growth again in the use of time-sharing systems and more recently computer networks has brought with it a growth in concern for the protection of information. So the nature of a threat that concerns an organization will vary greatly depending on the circumstances. However, we have some general purpose tools that can be built into computers and also operating systems that support a variety of protection and security mechanisms. So much of the work in security and protection is related to operating system that again can be roughly grouped into 4 categories. So we have availability, confidentiality, data integrity, and authenticity. So availability normally will be concerned with protecting the system against interruption. And also confidentiality will assure that users cannot read data for which access is unauthorized, so it's confidential. And also data integrity is the protection of data from unauthorized modification. Make sure our data is updated correctly. And there's also the authenticity will concern with the proper verification of the identity of users and also validation of message data concepts. We also have the scheduling and resources management. Here will be the key responsibility of an operating system is also managing resources and also coordinating it. So resources allocation policy must be considered. And this should give us improvement of these 3 items here: efficiency, fairness, and differential responsiveness. So in terms of, again, fairness, let's say we would like all processes that are computing for the use of a particular resources to be given approximately equal and also fair access to that resource. This is especially so far jobs of the same class, that is job of similar demands. In terms of differential responsivenesses, we say the operating system need to, again, to discriminate among different classes of jobs with different service requirements. So operating system should attempt to make allocation and scheduling decisions to meet the total set of requirements. And operating system also should make these decisions dynamically. For example, if a process is waiting for the use of an I/O device, the operating system may wish to schedule that process for execution as soon as possible. And also the process can then immediately use the device and then release it for later demand from other process. And lastly, the efficiency, as we know, operating system should attempt to maximize the throughput. Also should be able to minimize the response time in order, again, the process to be more faster and execute. Now, in some case of time sharing, it should be able to accommodate as many users as possible. So this example, we have a figure 211, and this is again the key element of operating system for multi-again programming. So this figure again suggests the major element of operating system involved in the schedule of process and also allocation of resources in multi-programming environment. So here we can see the operating system may have a system called handler, which is again a code. So a system call from a process. It may also have the interrupt handler, which the interrupt from process. And also we may have a short-term scheduler, which is a pass control to a process. So in this case, we have the long-term queue, short-term queue, and also I/O queues. So the operating system may maintain the number of queues here, each of which is simply a list of process waiting for some resource. So all these queues are again a code that need to be executed, the process, but again, they are waiting for resource. Now, the short-term queue consists of process that are in the main memory, or at least an essential minimum portion of each is in the main memory. And they are ready to run as soon as the processor is made available. Any one of these processes could use the processor next. Now it's up to the short-term scheduler or the dispatcher to pick one. Now a common strategy is to give each process in the queue some time to intend. This is referred to as the round-robin techniques. We may discuss this more detail when we cover again process scheduling. We also have the long-term queue. It's a list of new jobs waiting to use the processor. So this will be again the conclusion of our lectures in this section. So our main goal of these lectures is to focus on the major achievement in the operating system, especially in terms of multi-programming concepts. Always the operating system again receive control of the processor at an interrupt handler if the interrupt occurs. Also, a processor may specifically invoke from OS service such as input-output device handler by means of service call. In this case, again, a service call handler is the entry point into the process. The concept of interrupt or system calls, everything have to do with multi-programming, where we have more than or multi-process system. And again, we may discuss all this more detail in the future lectures. Thank you.